Hello? Yes. All right. Well, first of all, I want to thank you everyone for coming. I know it's Monday. It's already a tough day. And now we're going to talk about nerd stuff, which is going to make it even tougher. But thank you really for coming. I want to start with a short retrospective of my career, not because it's important, but because it gives context to the talk. Because right now I'm working on Storyblok, and I'm doing documentation and DevRel stuff. But before that, I was a design systems lead in a couple of companies. And before that, I was a product engineer, like probably most of you, working on a JavaScript web application on a daily basis. But before, I was a web developer for marketing agencies. This happened like a decade ago. And this is where most of the things that I'm going to talk about happened and took place. And what we were doing at these companies, we're doing mainly landing pages, like to promote a product or a feature. And we're also doing brand guideline sites. It's kind of like company websites that give to other people so they can download the official assets and learn how to use them. And the other thing that we would do a lot, actually, most of the time was promotional movie sites. Cool movies, you probably know them. And my favorite one were like social initiative programs. We used to do that a lot too. Some of these sites were this. It was super hard to get like screenshots of these projects because these projects like only last like maybe 1 year or two online, and they delete everything. So I managed to get this. The first one that you see is the Cars 3 promotional site, and the other one was some promotional thing between Guardians of the Galaxy and Doritos. But yeah, these sites like look really different, and the other sites that I did do look nothing like this ones. They were all pretty differently, but on the bare bones, like on behind the scenes, they would do all really similar patterns. Most of them were trying to be immersive and be like full screen experiences. So all the content would be in full height panels occupying all the viewport. And of course, people wouldn't notice sometimes that there's content below the fold because everything is quite centered and contained. And so we would have to have like these kind of like scroll indicators. User can scroll, but if not, you can tap on there. You will get like the next panel. We would snap these panels always on the top of the viewport, so this would actually never happen. But when you get the second panel or the next panel, something would happen. We would either animate the HTML elements coming in, play the video, even play the WebGL scenes. Like that's actually how it happened with the Cars 3. The other thing that happened a lot on these sites, some of them were US only, but others were like pretty international, so we had to cover a lot of languages, which was a challenge. And so this is pretty much, we could say, main characteristics of these kind of projects. Another one that they all share was the full of hacks. We were really trying to twist the browser's capabilities and what they could do. We're using a lot of JavaScript, trying to achieve these animations and these kind of experiences. And because of that, the code was also like really unmaintainable. It's not like we had to go back a lot to these projects because when they are launched, we barely touch it. But if you have to maybe come back to fix an after-launch bug, for example, there was a huge chance that you would create 2 more bugs after fixing that one. It was really common, and it's not a joke. We had really slow loading times. The main reason was that we were handling like really heavy assets, and like high definition images, videos, even the WebGL textures that we use would be like really heavy. And even after you loaded all the site, which would take a while, the performance was also bad, in part because of these hacks that I'm mentioning. So recently I've been thinking a lot because CSS have come a long way, especially in the last 5 years, web APIs too. And I keep thinking how much I would love to have the CSS that I have now, but 10 years ago while I was doing these really ambitious projects. And this is more or less like the topic and the essence of this talk, which is like, what are these new defaults that you and I already have ready to start a project, and how much I would have benefited from having those a decade ago. So a little bit about me, but really fast. That's my face. That's my name. As I mentioned, I do documentation at DevRel at Storyblok. I live in Barcelona, so I'm visiting here. Came for this and for the pastéis de nata. And I'm on Blue Sky, and that's my blog, in case you want to see my rant weekly about the web. And let's start. The first thing that I mentioned about these sites was this kind of like full height panel. And 10 years ago, that was actually an issue. It was maybe not in desktop, we can say that, but in mobile, it was. And the problem was this kind of like browser UI elements that appear when you scroll, like you have the URL address bar and the navigations on the bottom. And this would actually like kind of hijack that height, like if you put 100%, wouldn't work. We had a lot of UX designers working with us, not per project, but more analyzing general patterns around the things that we were doing. And they discovered that all people rest their thumb on the cell phone. So, so we find a hack. And the hack would be to literally listen to the touch start. And then we would remove, of course, this event and rely more on resize. We would do that. We would get the actual height of the viewport and then update all the panes because they were all like sections with an equal height. And the problem was that we thought that that's the first thing that you will going to do when you open the website. There's a huge chance that you do other things, so we have to cover that with a lot of events and then remove all of them. And this was really bad. It worked, but it was really bad. I don't like doing it. Now it's just one line of CSS. You just use dynamic view imports. This is like, I don't know if you can read that, it's like DVH, it's like dynamic viewport height. And that means that when an element from the browser shrinks the viewport, the element with that height will actually react and shrink with it. And that's like zero JavaScript, zero hack, zero guilt, which is more important for us. And this is it. So this is dynamic viewport units. I invite you to also check out if you haven't. One of these sites, for example, was the Facebook newsfeed promotional site. And you could see how this kind of like viewport animates, something that I was like explaining before. So, scroll animation. As you saw, the animation happens once you tap the arrow. And we would have to animate on the main thread. There was no other way to do it. We have to use JavaScript for this. There's no way out for that. So basically what you would do is just add an event listener to the button that does that. You would get what is the next pane offset top. And then you would, with an animation library, we were using a GreenSock fork that we had, and that was promise-based. At that time, GreenSock wasn't covering promises, so we made our own fork. But yeah, not super performant, if I could tell you. But honestly, the best and only way that we could do it at that time. So not so much guilt in here. Now it's much simpler. You would actually just get the next pane regarding the position that you are, and you would just call scrolling to view. Scrolling to view is a really old function. It was in Internet Explorer, so that's how old it is. But now on the element that is supposed to scroll, you can just do one CSS line, which is the scroll behavior smooth, and you would use even the native browser inertia. That would be way better. And this is called scroll behavior API. The next thing is the scroll snapping, this thing of the panels kind of attaching to the top every time. We didn't want you to be like with half a panel and half a panel, right? Like we didn't want this. We wanted to always be looking at the full section. And for that, what we had to do was a hack, of course. And we would hijack completely the scroll. This was actually awful. Like this is full guilt. I didn't like it. There were two reasons because of that. So this is pseudocode, but it's pretty much what happens, which is like when you scroll, the event object contains the x and y coordinates, and you can see if it's coming from a top scroll or from a down scroll. With that, you have the direction. With that, you get the current pane. With that, you get the next pane, and you scroll to that next pane. And the problem that this has is that a scroll actually is not a thing, because we can like detect the inertia of the browser and scroll with you. We would literally you would scroll, but nothing would happen with your finger, but we would detect and move. Yeah, it's like maybe the best that we could do at that time, but it wasn't nice. Now we have the scroll snap API for CSS, which is actually like super supported. It's new, but it was adopted by browsers quite fast. And the main thing that you will need to learn from this code is maybe the first line there, which is a scroll snap type. That gives you a couple of options how you want the scroll to behave. And then on each pane that you want to snap, you put like a scroll snap align, and you tell them where you want it to stop. And that's it. This is literally like no JavaScript. This already accomplishes the same thing as before, with a lot of upsides, because now actually when the user scrolls, the page will move, but it will attach to the closer pane that they have, which is way nicer. Way nicer. The other thing was scroll interception, and this is because you probably saw some animations on the video that I showed you before. And this is because we were detecting when a pane was entering the viewport, and when the pane entered the viewport, we would run certain things, start a video or something. So we need to know when the pane was entering in the scene. We wanted to detect it and execute something. At that time, we have to do another scroll event listener. And this is already getting, you're gonna see a lot of scroll event listeners. This was a performance problem. Like when you keep attaching event listeners, then each scroll feels like really, really bad in terms of performance, at least 10 years ago. So basically what we would do, so we would always like spy on the current position. We would detect these coordinates and we will run the animations, and we would also clean the animations. Why was this? Because performance was got such a big hit on these things that we need to also observe what was coming out and stop those animations or clean variables or like stop something from happening. Maybe a WebGL will need to pause like WebGL scenes if they were off screen, because it was impossible to actually make this usable. It worked again, but not super cool. And we have intersection observer now as a more modern alternative. This is actually not modern, in my opinion. This is really old, actually. It wasn't an Internet Explorer, but it's still old. It's super easy. This follows the observer pattern that's pretty much used by all the web APIs that are observers, which is that you instantiate one, pass a function, and say like what I want to do. So simple because this observer provides you entries with the is intersecting as easy, so it's an if. And if it's intersecting, you literally run the animations. If you want these animations to happen only once, so once the user already passed, you don't want to animate again, you can just unobserve the target, and that's as easy. So this is the intersection observer API. The next thing is web animations. We did a lot of animations. We were using, as I mentioned before, this green sock fork with more like promise wrapping. We use promises a lot because, and also we were using CSS animations, which actually were available when we were doing this, because the animations were really complex. We're animating like hundreds of elements per section, and we would use like CSS. That means that if you want to like touch the timing on one element, you will need to touch the timing of all the elements that are coming after. So doing this with promises was actually quite a better developer experience, and it was faster. And these projects were actually developed in a really short amount of time. So we were using this Greenstock promise wrapper, and that it was developed by us. Not cool. Also, it was like really, really heavy. And now you have the animation API. The web animation API comes on any element that you want. Like imagine that pane is an HTML element. You do that animate, and you just pass an array with animation objects. And interesting enough, this returns what is called an animation object. And this animation object has a finish property. So you can await that finish promise and then keep concatenating like animations. And this is like on, I think, all browsers already. I know that you will say, hey, but this is not CSS. But this is the JavaScript. I understand that. But actually, this is just a bypass for the CSS animation engine. This is all GPU accelerated. So what it does is just give you a JavaScript API for you to interact with the CSS animation engine. So performance is really good. this about internalization. This was a real pain, especially for testing and for fixing stuff. Let me tell you what was the main problem. The main problem is that we want the page to look nice and the layout to look nice in all the languages. And languages are really different. So somebody would report to you, hey, this title looks really small in Japanese. So can you make it bigger? And you would just see which element it was, get the class name, get the size a little bit high, and then you would do the normal thing, which would be to test your change in the other languages, and this will happen in German every single time. Or you would shrink it for German, and then it looked like a really stupidly small in all the other languages. That was really bad. Happened a lot. And right now you have better APIs. You have, first of all, CSS logical properties, which you should be using right now. Why are they important? Because instead of being padding top, padding bottom, padding right, padding left, they are padding inline and padding block. And why is this important? Because if you move from maybe a Western language that is left to right, and you move to another one like Arab that is right to left, you wouldn't have to actually tweak anything. The browser itself, when the attribute HTML happens to change, it just switches the access for you. So you don't have to do. We had a lot of hacks because of that. We have to detect which language attribute we have and manually change all the paddings and all the margins of every section of every element of every position absolute element. It was a nightmare. You also have these two things that are quite cool if you don't know about them. They're text wrap balance and text wrap pretty. What they do is pretty does something, it's still not super supported, does something really cool. That is that it prevents you from having orphans in text. So sometimes it happens that you have a long text and you have one word down. So pretty does this. Pretty makes some text I campaign in the last one, so it's not alone. Balance, what it does is try to, if something is, let's say, 3 lines or 4 lines, try to accommodate all the characters so they are all in similar length. And the reasons, I don't know the performance of this in terms of CSS, super cool, honestly. And also you have other ones like read and subread for layout that also react with the logical properties. They're really cool, more easy than what we were doing 10 years ago. I'm pretty sure that there are some other good ones that I'm missing now. But there are a lot of now upcoming CSS properties regarding font management and leading and space on custom web fonts that are really, really good. That'll be easy. And the last one that I'm going to mention today is view transitions. This has a special place in my heart because view transitions was literally, and I swear to you, the only reason that we were using a framework. We didn't need a framework for these sites, honestly. It wasn't a web app. It didn't have a business logic. We didn't have a state or anything. But the main reason that we were using React and Vue sometimes was because of this. We wanted to literally wrap a view on the transition element from the transition group, React. And this was a really good developer experience, to be honest. It's super hard to beat. Because we would get entering and leaving class names, and we would use that to actually coordinate the animations. It was really cool. It was really good. And nothing could beat that, honestly. We didn't have anything like that. But we were adding React just because of this. You need to understand that. And now you have view transitions. These are actually quite new, but they're being fairly quick implemented by browsers. And so you have, first, if you want to do it really simply and you want to have a fade in, fade out effect, you just put that thing on top of your CSS. And you can test it probably in Chrome right now only. And you will see how it fades in, fades out. But you can do even more complex stuff if you want, because you have also a JavaScript API with new events. You have the page swap and the page reveal. And this is basically the leave and the enter events for that. You can use an async function with promises, similar to what I showed you before with the web animation API and the finish property. And you can concatenate all the animations that you want. and then finish the transition with that. And that is pretty simple. So this is the web native alternative for this. These weird transitions. What happens when you combine all of this? Well, I created a really small demonstration that is literally doing all the things that these websites that I was building 10 years ago were doing. It has even the CTA that I showed you before. And when you click it, you see that it scrolls. All the panels are always full height. You will see that if I try to scroll up in the middle and I release, it would snap to the more that closer pane. So how do I do that? You also see the animations when the panel is revealing itself. And this is using pretty much all the APIs that I just mentioned. You can actually try it yourself. If you scan this QR code or start like typing this on your browser, I recommend you to do the QR thing. You can actually experience this on your phone. One of the things that is really nice to notice when you use this is actually the fact that the scroll inertia from the browser is not modified. It works as expected, it feels natural, the performance is good, the animations run like really smoothly. You will see that there are like small arrows below the API titles. That's if you have links if you want to learn about the API. If you open this in Chrome, you actually have the fade in, fade out effect. So I think that is still not supported in the other browsers. I think it's Chrome only. So you have to open it in Chrome. Chrome, not iOS. This QR code is less fun, but it's all the code for that site. And you can actually see how I achieved all of this. And I swear to you, like this is maybe 100 lines of code unminified to do all of what you just saw. It's like ridiculously short for what the site is doing in terms of capabilities and animations and complexity. So that's pretty much it. Thank you so much.